All right, guys, we are now going to learn how to find limits algebraically. We spent a lot of time talking about limits graphically, but now I want to take a look at what happens if you don't have a graph. How would you find the limit then? And there's really two main types of functions we can look at: constant functions and non-constant functions. Constant functions are super simple, super easy, and we're only going to spend a couple minutes on it. So let's take an example. Let's say I gave you a function f of x equals 4. That is a function. You guys remember what the graph y equals 4 or f of x equals 4 looks like? Well, any constant function is just a horizontal line. In this case, this one would be, let me change colors, would be at a 4, right? It would just be a horizontal line at 4. That is a function, okay? That's a function there. So the question is, for a constant function, if I asked you something like, what is the limit as x approaches -2, or what is the limit as x approaches 5? Okay, what would the limit be? Well, notice the notation. Okay, so here I say, what is the limit as x approaches -2 of 4? Which means the function is 4. Well, looking at the graph, everywhere the y value is 4. So no matter what value I'm looking at, let's say -2 is right here, no matter what value you're looking at, all those arrows are always going to be pointed towards a y value of 4 because every y value is 4 to begin with, right? So if you see just a singular number inside the limit, that just tells you it's a horizontal line at that number. Thus, the limit has to be 4. You could also see expressed this way. If I tell you the function is f of x equals 4 like I do, and I say, what is the limit as x approaches 5 of f of x? It's of the function 4. So that would also be 4 as well. Okay, so for a constant function, the limit is always just the number, is always the function, right? So the limit, I could give you another example, the limit as x approaches infinity of the function f of x, since the function f of x is equal to 4, that is also going to be equal to 4. It is always equal to 4. So anytime you see a constant, don't get confused by what the x approaching number is underneath. Don't let that get you. Just always know the answer is just going to be the function itself, okay, when it's a constant. Now, non-constant functions. Non-constant functions is pretty much everything else, okay? So the question is, what if I told you a function was continuous at point A? What would the limit be as we approach A? Well, you might be saying, well, how do I don't have the graph, how could I tell? Well, if something is continuous, right, we talked about what it means for a function to be continuous. If it's going to be continuous, we do know that the limit as we approach A, right, must equal a number. It must exist. So we know the limit as x approaches A of a function, if it's continuous, there must be an answer. 2, the value there must equal a number. And 3, right, the limit must equal the value, right? Or 1 and 2 must equal each other. Well, if the limit is equal to the value, or at a singular point where it's continuous, then the limit is simply the value at that point, right? Let's quickly just review that. If I know something is continuous at point A, I know at point A that this must be true. I know the limit as we approach A must equal a number. I know that the value at A must also equal a number, and I know that these two numbers have to be equal. So if those two numbers have to be equal, then the limit must equal the value. Thus, to find the limit, all I actually need to do is just find the value, because it will be the same thing as the limit. So let's see how that might actually work in real life. So let's take a look at this function, f of x equals 2x plus 3. Is that function continuous? Are there any jumps, gaps in the graph? There are not. You can put arrows here if you'd like. So this graph is continuous everywhere. There's no gaps or anything. So when I say, what is the limit as x approaches 1 of 2x plus 3, pretend you didn't have that graph there on the right. Pretend you didn't have that graph there. Could you still figure it out without graphing it? Well, the first thing you would say is, well, okay, is it continuous? Well, yes, the graph is continuous. But another thing you could do is just say, if I plug in 1 and get a value, if I plug in 1 and get a value, then that must be my limit number. So if I plug 1 into this function 2x plus 3, I get 5 as an answer. Thus my limit is 5. Okay? The limit as x approaches negative 2 of f of x. If I plug in negative 2, I get negative 1. And then if I plug in a, what's the limit going to be? It's just going to be 2a plus 3. You can just plug in the value. Okay? So what I want you to take from this is that to find the limit is if you plug in a value and get an answer, that is going to be your limit value. Okay? All you have to actually do algebraically to find the limit is plug the number, the x number, right? For example here, in for x, and if you get an answer, that's your limit. It's that simple. Okay, it's that simple. So let's move on a little bit. And it says, find the limits of the following. As x approaches 2, x squared minus 5x cubed plus x minus 7. Well, what I would do is plug 2 in for all the x values here. Right? I'd put a 2 in there, a 2 in there, a 2 in there. And you would simplify it, and if you get an answer, that is your limit. And I'll help you out here. If you plug it in, you get negative 41 as an answer. The limit as x approaches 0. Okay, what are we going to do there? Of that function, we're going to plug in 0 everywhere, and we're going to get root 2 as an answer, because these two terms, when you plug in 0, just go to 0. I would encourage you to now pause the video and try doing the next two. The limit as x approaches 2 and the limit as x approaches negative 2, and see what you get. Okay, so hopefully you pause the video. For the third one, I'm going to plug in 2, so I get 2 squared minus 4 over 2 plus 2. I get 0 up top, because 4 minus 4 is 0. 2 plus 2 is 4. So I get 0 over 4 or 0. So the limit is 0. Okay, the limit is 0 there. But if I try plugging negative 2 in for the next one, I get negative 2 squared minus 4 over negative 2 plus 2. That equals 0 over 0. Guys, that does not equal 0. If you said it's equal to 0, luckily I cannot see that you actually did that. You cannot divide anything by 0, not even 0 itself. Okay? Okay? We cannot do this. So, oops. What is our answer in this case then? Okay, well, here's a little helpful trick for us. So when plugging in a, okay, when plugging a into a limit yields you an answer in the form 0 over 0, like we just saw. Okay, it is said to be indeterminate. And now what that means is not that the limit does not exist. The limit actually in this case does exist. In short, it just means we need to do a little more work to find out what the limit is. Okay, so let's walk through this together. So I had the limit as x approaches negative 2 of x squared minus 4 over x plus 2. Well, you might have noticed that the function here inside can be factored to x plus 2, x minus 2, all over x plus 2. The plus 2's cancel out, and I'm left with x minus 2. So those two functions, the original one and x minus 2, are really equivalent, right? All I did was simplify it. So if you were to actually, I wouldn't want you to normally do this, to normally graph it, but I want you to see the graph to actually see what's going on. So if I actually make a graph of x minus 2, that means we have a y-intercept at minus 2, right? And we have a slope of 1. So we would get a graph that looks like that. But notice, okay? So the graph of this, x minus 2, would look similar to the original graph given. Okay, it would look identical actually except for one thing. And I want you to think about what that one thing might be. What would look different on the graph of x minus 2 versus the original function? Well, notice here, I canceled out x plus 2's. Now remember, when you cancel out things, think back to rational functions. What happens when you cancel out things? You get a hole in the graph, okay? And where would the hole in the graph be? It would be at what makes this term 0. right, at negative 2. So the graph of x squared, of this guy right here, x squared minus 4 over x plus 2 would look identical to x minus 2, with the exception that you're going to have a hole in the graph right there. You're going to have a hole in the graph. So now, when you think about plugging negative 2 to find the limit, why didn't it give you an answer? Because that point doesn't exist on this graph. It doesn't exist there. So how could we find out what the limit is? Well, the nice thing is that after simplifying it, the limit as x approaches negative 2 of the function x minus 2, right? If I plug negative 2 into that form, I would get negative 4 as an answer. Okay? And that is indeed our limit. That's where that open circle right here would be. That open circle would be negative 2, negative 4. Okay? So when you have something in indeterminate form, if you plug in a value and you get 0 over 0, that means you need to factor or simplify the function first, simplify it, and then try replugging the value back in. Replugging the value back in. So again, when you get 0 over 0, that typically means there's a hole in the graph. To figure out where that hole is, you have to simplify it and then replug the function back in. You can see graphically, right? As I approach negative 2 from both sides, both of my blue arrows are pointed towards negative 4, so I feel confident, okay, that that is correct. All right, so it says find the limits of the following. Now, there's not really too many tricks going on here. I would encourage you to pause the video, okay, keeping in mind what we just learned, and see if you can figure out the answer to these 4. Okay, so pause it, see how you do, and then come back and check your answers versus mine. Okay, so hopefully you paused it and got somewhere. When I try plugging negative 1 into the first one, I get 0 over 0. That means it's indeterminate, meaning I need to simplify it, try to cancel some things out, and plug back in. So the numerator is the numerator, I can't factor that, but the denominator factors to x plus 3, x plus 1, they cancel out, and I'm left with 1 over x plus 3. If I plug negative 1 in now, will I still get 0 over 0? I do not. Actually, I'm left with negative 1 over 2. Thus, my limit is negative 1 over 2. Again, notice I tried plugging negative 1 in first, and I got an answer. You should always plug a value in first. Don't immediately jump to factoring. Always plug a value in first. Then, if you get 0 over 0, then you factor. The next one, if I try plugging in 4, I get 0 over 0 again, indeterminate. I need to simplify this. So the first thing I would do is factor out a negative 1 from the denominator here, and I would get x squared minus 16. If you factor out a negative, I just rearrange the terms, which would give me x minus 4 over negative x plus 4, x minus 4. By factoring out that negative, it allows me to cross this out, and I'm left with y equals negative parentheses x plus 4. If I plug in 4 now, I do not get 0 over 0 anymore. I actually get negative 1/8. So you get negative 1/8 there. Now number 3 is a little bit trickier because I really can't factor it. It's already factored. But notice, and maybe you guys tried this, if I FOIL out that x minus 1 squared into x squared minus 2x plus 1 minus 4 over x minus 3, and then combine, I get x squared minus 2x minus 3 over x minus 3, which factors to x minus 3, x plus 1 over x minus 3. Now those x minus 3's cancel out. I'm left with x plus 1. If I plug 3 in, do I still get 0 over 0? I do not. I get 4. Thus, the limit is 4. And the last one, hopefully you got this. Notice, yeah, you certainly can't factor or simplify. Remember that pi is a constant. Meaning the graph of pi is just a horizontal line at y equals pi. Every y value has pi. So as I approach 3, okay, what's the limit going to be? Well, it's just going to be pi. Remember, the limit of any constant function is just that function itself. Okay, so the limit as x approaches 3 of pi is pi. All right, just to summarize, guys, to briefly recap, in order to find the In order to find the limit of a function algebraically, first, and I can't stress this enough, you must try plugging in a value first. Do not jump to factoring right away, because if you do, and you actually can plug it in from the get-go, you can sometimes get different answers. So do not do that. Try plugging in first. Okay, try plugging in first to see if you get a different answer. If, number 2, now if by plugging in the value we get an indeterminate form, meaning, right, indeterminate means 0 over 0. If you get 0 over 0, okay, I would say try simplifying the function and then try plugging in again. And by simplifying, I mean factoring or foiling. I should capitalize that. Foiling, then factoring. The example in number 3 above on the last page was an example of foiling, then factoring. Okay, so it's pretty simple steps. Plug in the value. If that doesn't work, you get 0 over 0. Then you factor or FOIL from there, okay? Under the homework section, number 1 could be a little bit tricky. It's pretty simple, but tricky at the same time, so be careful. 2, 3, all these guys, just be careful. Try plugging in and factoring. If that doesn't work, see if you can get creative with what these limits are. And we'll talk about it more in class the next time.